Hello friends, welcome to my channel Easy Learning with Sangeeta Mehta. Today we will be doing Class 9, Chapter 1 Number System, Exercise 1.3, question number 4 to 9. Question number 4 is express 0.99999 in the form P by Q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. So, let x is equal to 0.9999. Let this be equation 1. In this equation, one digit 9 is being repeated. So we will multiply equation 1 by 10. X is equal to 0.9999 is equation 1. This is multiplied by 10. We get 10x is equal to 9.999. This becomes equation 2. Now subtract equation 1 from equation 2. 10x minus x is equal to 9.999 minus 0.9999. So 9x is equal to 9.9 minus 0.9. 9x is equal to 9. So x is equal to 9 upon 9, which is equal to 1. So we conclude that when x is equal to 0.9999 and x is also equal to 1 as we have seen over here, so 0.999 is equal to 1 upon 1. This is in the form of P by Q as is asked in the question. We move on to question number 5. What can the maximum number of digits be in the repeating block of digits in the 1 decimal expansion of 1 by 17? Perform the division to check your answer. So we have to divide 1 by 17. When we start dividing, we will realize that it continues on and on. 1 divided by 17 is equal to 0.0588235294117647. Now after this digit 7, the numbers will again repeat 0588235294117647. As we can see over here that the remainder is 1, which has been repeated again after remainder 1, which has happened after 2 steps. So this is non-terminating but recurring. And as is asked in the question, after how many digits are the numbers being repeated? So we realize and we observe that after 16 digits, these numbers will be repeated. When we get remainder 10, these 16 digits will repeat 0.0588235294117647. We move on to question number 6. Look at several examples of rational numbers in the form P by Q, where Q is not equal to 0, where P and Q are integers with no common factors other than 1 and having terminating decimal expansions. Can you guess what property Q must satisfy? We take example 1. 4 upon 5 is a rational number in the form P by Q, where Q is not equal to 0 and where P and Q are integers with no common factors other than 1. When we divide 4 by 5, we get 0.8. So this is a terminating decimal expansion. In P by Q, Q is equal to 5. We take another example, 7 by 2. When we divide 7 by 2, the quotient we get is 3.5. This again is a terminating decimal expansion. In this P by Q, Q is equal to 2. The last part of the question says we have to observe and guess what property Q must satisfy. So, in these examples, Q should either be 2 or 5 or 2 to the power m multiplied by 5 to the power m. Q is equal to 2 to the power m multiplied by 5 to the power m, and Q is the denominator. So if Q is equal to 8, it can be written in the form of 2 multiplied by 2 multiplied by 2. This is equal to 2 to the power 3. Now if Q is equal to 4, it can be written in the form of 2 multiplied by 2, which is equal to 2 to the power 2. If Q is equal to 125, it can be written as 5 into 5 into 5 or 5 to the power 3. Now if Q is equal to 25, it can be written like 5 multiplied by 5, which is equal to 5 to the power 2. In these cases, the decimal expansion will be terminating. We move on to question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. We know that when we do decimal expansion of all irrational numbers, we get non-terminating and non-recurring. We can write irrational numbers like under root 2, under root 3, pi, but then we have to write their values. Instead, we can write irrational numbers which are non-terminating and non-recurring like 0.505, 005, 0005, 00005, and it continues. Another number we can take is 0.01, 001, 0001, 00001, and it continues. The third number which we can take is 0.808, 008, 0008, 0008, and it continues. We move on to question number 8. Find 3 different irrational numbers between the rational numbers 5 upon 7 and 9 upon 11. So we start by making 5 upon 7 and 9 upon 11 in decimal form. So 5 divided by 7 is equal to 0.714285. Here we observe that we have got 5 remainder over here, which has reoccurred after 5 remainder, which was in the second step also. So we get the quotient 0.714285. After 5, these numbers repeat again 714285. So we put a bar on top. Moving on to the next part, 9 by 11, we divide 9 by 11 and we get 0.81. In this question again we observe that we get remainder 9, which was there in the second step also. So the quotient 0.81 has these two numbers repeating again, 0.81, then 81 and then 81 again. So we put a bar on top. We have to find three irrational numbers between 0.714285 with a bar and 0.81 with a bar, or numbers between 0.71 with a bar and 0.81 with a bar. So we get numbers. We can write many numbers between these two. The first number that we can write is 0.72072, 0072, 00072, and it continues. The next number we can take is 0.730, 7300, 73000, 73, and so on. It continues. The third number we can take is 0.760, 7600, 76000, 76, and it continues. So we have got irrational numbers between 0.71 and 0.81. We move on to question number 9. Classify the following numbers as rational and irrational. The first part is under root 23. Since 23 is not a complete square of any number and it is a prime number, so under root 23 is an irrational number. We move on to the second part. Under root 225. We prime factorize 225. We find that 225 is a perfect square of 15. So it is a rational number. We move on to the third part, 0.3796. The decimal expansion of this number is terminating. So it is a rational number. We move on to the fourth part, 7.478478. It is non-terminating as it is not finishing. Also, 478 is repeating, so it is a rational number. 7.478 with a bar on top. Irrational numbers are non-recurring and non-repeating. So this number, since it is repeating, it is a rational number. We move on to part 5. 1.010010001 00001. By looking at this number, it is clear that it is an irrational number as it is non-terminating and non-recurring. So with this question, we finish exercise 1.3. I hope all of you have understood. So friends, please subscribe and continue watching my videos for the next exercise. Thank you. Have a wonderful day.